Where is this? There we go. Okay. I think I'm recording. Yes, I am. Great. Okay, let's get started. So here is my model. I'm gonna make sure I got all my steps here. Okay. Yeah, so let's start by walking through the data. Okay, so we go to my code here. All I'm doing is I'm really just inputting this one file. It's a text file with some basic traffic data. It's nothing that's too deep or too big. It's not making that much of a effect, but that's where this happens. It's right here. Pretty simple, right? Throws it in. Let's make sure I got everything here. Data on your code models. Okay. Yeah, let's break down the code. I'm gonna go through all the lines for it mainly. So it's just like show you how you implement at least three design concepts. I mean, you'll see how I've done all of them here. So let's just start from the top. Again, we got globals, very basic, right? We set up, and then okay. So here I have my PY core, PX core. This is just drawing my roads. It colors the intersection in. So I got, bang, bang throughout. That's 25s, 26, 24s. So one, two, three patches all the way. So bam, 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 like that. Next is just drawing these ones right here. I'm making these ones white. Right there, right there, right there, right there. It's kind of a nice way to indicate where the car should stop. I wish there would be like a darker gray or something, but it's just a spot on the road that the cars will stop at if it's a red light for them. Next, we got all the roads that are going out. So again, more gray, and these just draws every single one that was Valpo gas station, US 30 Valpo. As you can see, it said be like that road, these six total. Next, I kind of made little like blocks for where places would be. Like here's Valpo, the gas station, the shopping center. So shopping center, gas station, Valpo. Pretty easy, right, with their corresponding colors. And then I wanted to just finish it. So I was like, okay, let's just everything that's left that's black still, because it starts out black, set them green, and that's what makes the green grass around it all. So that, and then I also just recolored in black patches for death spots. So that'll be like the entrances here, here, and here, which I'll break into more. And then to the percentage of congestion of how many colors are red in total, which are just congested guys. So then to go, count the current time once, tick, obviously, change the traffic light, run that procedure at every tick, basically, every time we get to the go. This isn't needed anymore. I like it up there, as you can see, because it just shows how the code slows down when there's too many cars on the road. And then I have this here every like 300 ticks. Ask to add cars. So call the next add cars function. We'll get down below. And every 1,000 export congestion data, which is another um, sub procedure down below. So ask those two, then ask turtles. If there's someone ahead of them, turn red. Pretty basic, right? So if someone's ahead of you, you're going to be a congested car. That's how I know how many cars are congested. Moving on, okay, so how this works is I have four different big if statements for the four. I could use a case switch here, but this one's going to be is the y-axis green and the red and the x-axis red. Again, kind of same below for all of them. And how this works is, and it's be green, red, green, yellow, yellow, red, and then red, yellow. Yep. How it works, I won't break down all these because I mean they pretty much are just copy and paste of each other with a little bit of differences. Let's do green, Y, red, X. So again, they can move up and down. They can't move red, right at the green light. So ask turtles if they're heading north or south. So if they're up or down, and if there's no one ahead of them, let them get a random speed value and move that random speed and make sure they are blue. Anything else, make sure they're stopped. Then for this one, if they're going 90 or 70, so if they're going east or west, and they are on the white one, we got a red light. So that means they need to stop. They need to stop there. Same thing too. If no one's ahead of them, then they can move. So that's how that works. How I have yellow working, it's the exact same except for cars that are moving through a yellow light, they speed up a little bit so they can try and run the light, if that makes sense. So here's their distance. If they're close to the light, move a little bit faster. So It looks like it would move slower too here, forward 0.05 instead of the random flow, but it executes much quicker, so it actually just goes faster. As funny as that is. Because I had that set to like zero point 0.1, just have them go the fast speed and they zoom through the light. It looks very unrealistic. So that's how all these work. Pretty great there. And then this is asking to randomly turn. I fiddled with a bunch of different random values. I found just one out of or 1 out of 100 like this, so was the best way to do it. So if they're at a certain patch, and these are all the patches, all these ones here are going to be this patch, this patch, this patch, this patch, this patch, this patch. So if they can turn, basically, ask them to turn maybe. And that's how that works. I mean, it's pretty simple, right? Set their heading differently so they turn and they keep moving. And it works fine with the code above because they won't even run in the light. So they can just keep rolling. That's have to use patches to find out if they're at the light or not. Uh, Here we are. Oh yeah, if they hit a black patch, so if they hit one of these patches here, or you can't use black because I also have them dying if they hit up here, 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 they die, or they just go away, so they disappear, or if their P color's black, like I said, yeah. So this one's for the intersection, this one's for the going into some other place. Then to the congestion, and that is the entire to go function. Moving on to export congestion data, I'll open this congestion data.txt file, and we take a zero, just file print the header for it, I guess. Yeah, basic. And then get the time, get all, yeah, just, I mean, it's pretty simple, right? Just read in all these values, close it, and you're able to kind of see how the congestion changes over time. That's great there. And this gives you percentage value too. So we're finding how many turtles divided by 100. To add the cars in, let the base population be the population. So how this works is if this is set to zero, which someone commented that, that's not realistic to have it at zero. I'm treating this as no one lives in Valparaiso. I want to be able to test all the cases. If it's at one, that means 10,000 people live here, 20,000, etc., all the way up. So that's the base. If it's the weekend and it's a semester, we're going to kick it down a little bit. That means there's going to be a little bit less people driving on the road on the weekend. If it's not the weekend, it's during the school semester, then it's going to go up a little bit. More traffic during the Monday through Fridays here. People are going to class. If it's the weekend and it's not the semester, knock it down a lot. So weekends have a lot less traffic on that road. And especially if there's no school in session, it's summer or it's winter, there's a lot less people here. So knock it down two. If a sports game's going on, up it by two. Something's going on, there's people here, a lot more people are driving. And if it's popcorn festival, knock it up a lot. That's when we see the most congestion in Valparaiso every year. It's during the popcorn festival. So up take it to about 40,000 more people coming in and out of the campus. 40,000, but that's just a base number to kind of go off of. With this, we're going to get a number. And let's say the base population is five. And what's an easy one? Let's just say weekends true, semesters true. Okay, so -1. I said base population is five. That one, so now it's four. We're going to repeat this every 300. At the very top, I said every mod 300, run this to add cars function. It's going to take that number four and subtract it by a random number between 0 and 6. So we can spawn four cars, three cars, two cars, or one cars at every spot. I had it running before where I just ran this once and it would spawn exactly three cars at each spot or no cars at each spot. Now it's a random number every single time. So we can get four here, zero here, one here, two here, or all zeros, all fours. It's all random. Now, if it gets kicked up to 10, we have this value up here at 10, let's say we get from these calculations, then it'll be either 10, 9, 8, 7, 6, 5, or 4 corresponding no matter what at every single spot at all those times. Hope that makes sense, and then obviously you set shaped car, color in blue, so they're heading, make them go. Spawns about all their spots on the road. Change traffic light, and this is kind of the end of the code here. This is simple. If I messed with a bunch of different tick times, I found this to be the best for me. 0 to 1,300 ticks, it's green and red, and then give it about a 300 tick block for yellow, 1,300 again for red and green. Yeah, red, green, and then 29 to 32 for red, yellow, and then reset. Again, all we're doing here is we're just setting the patch colors different, and we're just setting the light color so we know which part of the if block to use up here. Um, and if we go over, reset to zero, because then we'll just jump right back up here and it's a continuous loop. We just loop through these if statements. What else was there that I had to talk about? Oh yeah, we gotta do the model. So a base case, I'd say, what was it? 34,000 people live in Valparaiso. We'll give them 30,000 people. This is in 20. Actually, you know what? We'll say four because probably more people live here since 2023. 40,000 people live here, and it's what's today? It's a semester. We're in the semester, and it is not the weekend yet. Go. Got some cars spawning in. Pretty basic, I would say. Normal. It's running just fine right now. Get my ticks are a little slow. Let's kick that up a little bit. There we go. It looks a lot glitchier on screen. I think it's because I'm running Zoom right now. Ah, jeez. The Zoom is making it way glitchier. My computer's slowing down a bit. So, anyways, this is it running through a base scenario. Now let's reset it up. Say population is 30,000, and it is not the semester. It's the weekend. There's not a lot of people here. Go. A lot less people spawning in. Shoot, we have no one so far. We're randomizing through two. One guy to come. Two guys come. Couple people blowing through here. Very minimal. And we're seeing not much congestion, right? So if it's during the summer, it's a weekend, not going to be many people in Valparaiso driving around. Last but not least, let's knock it back up. Let's go to 50,000 people live here right now. It's a semester, it's not the weekend, and oh my God, it's the popcorn festival. Or that'd be on the weekend, wouldn't it? So it'd be Saturday. And why would they schedule a football game too? It's crazy. Bunch of people. Right, we're getting very congested. You can see the congestion numbers just shooting up here. And you can see little spikes in it, and that's because, light will open up and everyone gets uncongested because they can move then. But we're able to see, different time variables of how many cars are here, how many cars are stuck. Again, this gets just crazy going, but that's pretty realistic to what would happen on the Popcorn Festival. It's very backed up here. There's a lot of people coming into town these days. What this is very helpful for, though, too, saying, okay, it's the Popcorn Festival. That'll be on the weekend during school. We only have 20,000 people living in Valpo. It's not terrible. So, this is able to give us data on how well could Valpo manage. Now, we say, oh my gosh, the population of Valpo is at 80,000. We need more roads, or we got to figure something out because there's way too many people trying to come through here when there's 80,000 people living in Valparaiso during the Popcorn Festival. This is not going to work for our community. We got to find a different way around this. This is way too backed up. That's how this is intended to be used. That's my big question is how can we really figure out futuristic traffic congestion with certain given variables like a sports game, weekend semester, because I mean that's what's big here. It's sports. It's the school. School kind of runs this town, Valparaiso, and the Popcorn Festival. Those are big things. And then populations are one thing that will be changing over the years. It seems like the rest of these will probably be staying. What else is left to talk about? I spoke about the design concepts as I went through the code. I think I broke all this down. Yeah, awesome. If there are any questions, comments, or concerns, please let me know, and I'd be happy to break this all down in a better way if that's possible. So, thank you.